right, so yeah, that is actually a little background about how I ended up in medical geology, because if we continue, I mean, at a certain level of our research, I think we need to start thinking, how can we make our research beneficial to the society and not just decorating our CVs with publications and impressing our leaders and institutions with high impact, high citation index. And I think in 2025, it's time to do research that can benefit the society as a whole. I'm not undermining basic research, but it needs to lead to something that is more beneficial. Okay, I give you a flash disk, and you can just use your own. Yeah, of course. I already mentioned this. Okay. Yes, it's there. Okay, let me just help you to find it. No problem. You can just go to I can show you. I exhausted all my jokes now, so I think we have to be serious, otherwise you will sleep. Close that one, yes. Close that one. Okay. It's the flash disk. Where's your flash disk? That one? Yes. Okay. And that one, yes. I hope the PC can understand the Mac. Okay, so we're moving from Apple Macintosh to PC. I hope they understand each other and that I can read my files, because sometimes there is conflict of interest between the two. You didn't send another copy of your talk beforehand? No, I did not, but it's on flash disks. Okay, here we are. Okay. Can you put this thing there? Yes, please. Thank you. We are getting there with our natural intelligence. Right, okay, I think we can move to the next slide. I hope it will work. Or maybe you can just pass the slides for me. Yeah, please, I think likely our intelligence work. All right, so the relationship between environmental and health were invoked by ancient scholars and physicians, including the father of medicine, who stated, if you want to learn about the health of a population, look at the air they breathe, the water they drink, and the places where they live. Of course, we cannot forget the genes, which are also controlling our health. As Dr. Davis, an American epidemiologist, said, the genes give us the guns and the environment pulls the trigger. So what is this environment? Next slide, please. What is this environment that I would like to discuss about today with you? We can summarize our environment into two main categories, what we call anthropogenic, which is all about man-made, and what we call geogenic, which is more natural, or the geo-environment. To all this, we add, of course, mining. I put mining as an intermediate between the two, because if there are no natural resources, there will be no mining. So it's a combination of the two. I will stress mostly on the geogenic environment. The reason is, one, when you have industrial city, or you see the cars, the pollution from the cars, or plastics in any man-made pollution, you know what to expect. You can see it. When you have a mine, you know what to expect. You can see it. But the natural environment is the most dangerous because it's hidden. You don't see the impact until it's late. So this is what we focus on in medical geology. Next. Yeah, it's working. Okay, good. So the geo-environment, or our geo-environment, we all know that we are surrounded by mountains. The mountains are made of rocks, rocks are made of minerals, minerals are made of chemical elements. So depending on the composition and concentrations of these chemical elements, we have beneficial or harmful impact. Essential elements that are found in our surrounding environment, in soil, in water, which are generated from the rocks, such as selenium, iodine, iron, fluoride, magnesium, calcium. These are all elements that are needed for our well-being. But we also have what we call toxic elements, which are also present in this environment, because rocks, as I said, they are made of minerals, and these minerals contain different types of chemical elements. I know for the non-geologists, rocks are just one stone. But for geologists, there are several types of stones. Each has a different composition than another one. So each of them carries a certain concentration of chemical elements that is different than another rock. So some rocks contain toxic elements such as arsenic, cadmium, lead, and so on. And then we can also have what we call potentially harmful elements, which can be all the essential elements if they are present in doses that are not healthy for our organism, then they cause harms to our health. Then we have minerals, of course. I'm sure you all know about asbestos, which is a commercial name for a certain group of minerals. Due to their form, they can be harmful to our health. I will illustrate with some examples later. So what are the geological processes or factors that are enabling these chemical elements that are present in minerals or in rocks to be released into environment and then bring them to contact with our bodies? Volcanic eruptions, dust storms, earthquakes, rocks weathering. When rocks weather with time, they form soil. So whatever found in the rock will be released into the soil. Dust, when there is drought, dry seasons, soil can turn into dust, and then inhaling these nanoparticles, it affects our health. Then we have also the rock and soil-water interaction. When there is interaction between these components, chemical elements that are found in rocks or soil, they are released into water. The concentrations of such elements in drinking or irrigation water used for bathing is what brings them into into the contact with the humans and animals. You can see there, for example, rocks. The color of the rocks there is red. The soil is red because the soil is weathering of the rocks. The same here for water, and the same there for dust. So what is the impact of this geo-environment on our health? It has direct and indirect impacts on our health, the ecosystems in general, and forms part of the contributing factors to a number of what we call NCDs, which are the non-communicable diseases. I will explain a little bit later. As a result, this impacts the socioeconomic development and achieving the United Nations SDGs. So what is medical geology? Medical geology is a discipline that examines the impact of the environment, geological material and processes on humans and animals' health and the ecosystems in general. Medical geology deals with the cause of the disease, not the cure. So we are not medical doctors. If there is any medical doctor here, you are safe. I'm not taking your position because I cannot treat any patient. So this discipline is based on an multi, and cross-disciplinary approach, bringing together geoscientists, environmental scientists, biologists, biochemists, and so on. So basically, everyone can contribute to this, to research in the field of medical geology. So what are the exposure pathways? As I mentioned it earlier, these elements that are released into the environment through geological processes, they need to reach our body. How? Through dermal contacts, drinking, irrigation, okay? Through ingestion of food crops, and through inhalation of the air. So any of these three pathways will enable whatever is in the geo-environment to enter our body. But what is controlling the effect of the geological material on our health? Two things, the exposure and the dose. Long-term exposure to low concentrations of toxic elements has the same effect as short-term exposure to, to high concentrations. For example, if you are living in a house that is built with rocks that contain a uranium-bearing mineral, even if it's small dose, but if you live in that house for years, you might be affected in a longer term. The same effect if you are exposed to radiations, high radiations. So the notion of exposure is very important. The dose. Harmful health effects, including death, can result from high or low doses of essential elements. I mentioned it earlier that some elements like lithium, selenium, iron, magnesium, they're very important for our well-being. But too much of that or too less of that is not good, okay? And high doses of toxic elements is never good in any case. So I come back to the essential elements. When I say high dose of essential element is not good, it's basically when we say, like I say, too much of anything is too much. I hope there are students here, but I don't think there are students, but there are, I'm sure, online. I always tell my students that too much of anything is not good except for studying. That will never harm you. So I hope they are still listening and applying this rule, which is against the rules of toxicology. Then, of course, this corresponds to what we call recommended daily allowance. Each chemical element that is essential for our health has a daily recommended dosage that we need to respect. So what else? What is controlling the impact of these elements? Of course, we have what we call bioaccessibility, bioavailability. I'm not going to enter into all these, the definitions of these terms, except if someone needs that later I can explain. But most importantly, the optimum balance. What do we mean by optimum balance? I try to explain with an example. Calcium. We all know calcium is needed for our bones, teeth, and so on. In addition to that, it helps nerves carry messages between the brain and every part of our body. So we must not undermine the role of calcium. It also helps release the hormones that affect many functions in our body. The daily or the recommended daily allowance for each category of age differs, but given that today I thought we will be around between 50 and 70, so I choose this category to illustrate. So the recommended daily allowance, if you are between 50 and 70, it's 1,200 milligrams per day. But too much of calcium, if you take more than this, it compromises the uptake of magnesium, which we also know is very important to our well-being, to our body. For example, magnesium regulates several biochemical reactions, including the muscles, the nerve functions, the blood glucose, and even the blood pressure. So you don't want to take too much calcium to strengthen your bones. Meanwhile, you are compromising the role of magnesium in your body, especially leading to blood pressure and so on. And of course, too much of it can also cause what we call hypercalcemia, which is a serious disease that can lead to kidney, heart, bones, and brain damage if it's too much. I'm sharing this example just so that you know everything needs to be balanced. And it's not about the tablets that we take from the pharmacy. It's about our environment. It's better to have all these elements incorporated through the food crops, through water that we drink, instead of going to the pharmacy and use supplements. Now, what are the geological processes that are on material? I would like to illustrate with some examples. I mentioned about this as part of what is controlling our health. So I will illustrate with two examples of chemical elements, one example of minerals, and two examples of geological processes, just to give you an idea of what is what. Toxic elements, I'm sure you all know about arsenic. From a geological point of view, arsenic is one of the 20 most common elements in the Earth crust. It is found in rocks and therefore soil and water, because we mentioned about alteration, weathering of rocks and interaction between rocks and water. Depending on the valence state and the different environmental conditions, we have different types of arseno-bearing minerals. For example, we have arsenolite, we have arsenopyrite, we have orpiment, we have realgar. As you can see, they are all beautiful minerals, but they contain arsenic. That's what makes them ugly at the end. So arsenic can also be present in rocks, in a mineral that is found in a rock, such as this one, for example. But sometimes they are found, you cannot see them microscopically, you can only see them under the microscope. For example, if you look at this scanning electron image, you have pyrites, you have arsenopyrites, and there are tiny inclusions of arsenopyrite in coal. And people who are burning this coal for daily use can be affected. So even though you don't see it with naked eye, but it's there, and its effect is hidden behind the processes under which coal is used. For example, how it reaches our body, as I said, through drinking water. Sometimes you have nanoparticles of minerals that contain arsenic floating in the air, coal combustion, as I mentioned, even in food, such as rice, dried chili, and so on. This is typically happening in China, in one of the regions of China where there is high amount of arsenic, microscopic arsenic in the coal, which is used for combustion. And also the water that interacts with coal is used for irrigation for rice. Therefore, it accumulates also in the rice. So the World Health Organization guidelines is about 10 micrograms per liter. I'm sure you all heard about Bangladesh crisis years back, where the arsenic content was about 50 microgram per liter, which caused a serious health issue, and that is all in geological formation. It is not anthropogenic, it is geogenic. And thanks to the contribution or the interventions of geoscientists, they found out the source of arsenic, and then they came up with remediation techniques that helped people to reduce the impact of this pandemic. Oh, sorry, I have to go back. Okay, sorry. Okay, from a health point of view, the presence of arsenic in our environment, whether it's water, air, or food, or any media that is in contact with our body, it can cause a number of or different types of cancer, including skin cancer, lung cancer, bladder, kidney, liver, prostate, and so on. All kinds of cancers. Cardiovascular diseases, respiratory diseases, diabetes, neurological and neurobehavioral effects. Sorry that I had to put these pictures here. They are real examples of situations, most of them in Bangladesh and China, where water was extremely highly concentrated in arsenic. So all these diseases that I listed here, they are the 4 that were listed by the World Health Organization, as the leading causes of death, or what they call the threats. I would like to illustrate now with an essential element, fluoride. Fluoride is found in also geological environment. It can be released through volcanic eruptions, but it can also be released by interaction between volcanic rocks and water. So you can find it in water, you can find it in food crops, and so on. So mineralogically, it can appear like this beautiful mineral here, which is fluoride. This is apatite, where the chemical composition has fluoride in it. It can also occur in a rock, under these greenish spots there, and under the microscope in tiny microscopic minerals. So it is present basically in all kinds of environments. How does it, what is the exposure to our body? Again, through the interaction between water and rocks and withering of rocks, and of course, drinking water that is contaminated with these natural elements, or the food crops that are irrigated by this water can affect our health. What are the health effects? Before that, I want to tell you that given that it is an essential element, there are recommended daily allowance between 0.5 to 1.5 milligram per liter. It's very good. But Above that or below that, it's detrimental. So here we are now about the right dose. Apart from dental and skeletal fluorosis that we know, all of us, it's the main health issue that is caused by excess or deficiency of fluoride in our diet. Recent studies showed that it can also lead to cardiovascular diseases. I pause here to explain a little bit. From a geological point of view, chemical systems or rocks that have fluorine in their composition, usually they are highly enriched in sodium, potassium, and chloride. So if there is high potassium, calcium, and chloride in the environment, what does that mean? It means the water has high salinity. What does that imply? High blood pressure. So the excess of fluoride in the system is not the one that is causing directly the cardiovascular. It's the whole package together. So the fluoride is an indication. If there is too much fluoride, there is an issue with salinity, which means that it can also affect the cardiovascular system. It can also affect what it calls bone cancers. Again, it's not the fluoride itself that is causing the bone cancer. But when the bones are weak because of lack or sufficient fluoride in the environment, what happens? The bones deteriorate, and that leads to bone cancer. So this is an indirect. While dental and skeletal fluorosis is a direct impact of fluoride, the cardiovascular and the bone cancers are indirect impact. So I hope some of you are not sleeping. I see some eyes closing. So I don't have my hammer with me to knock. So please stay with me, don't sleep. We still have a long, long lecture. In addition to the bone cancer, there's also evidence of diabetes and diabetic microvascular complications. Again, if you look at these diseases, they're amongst those 4 leading causes of death as defined by the World Health Organization. Just keep them in mind, and we will see towards the end. All right, now, minerals. I don't know if there are geologists here, but I think I'm the only geologist. So what I heard in the past, when I read also, a lot of people call it chemical elements a mineral. So in geology, mineral is a mineral, chemical element is a chemical element. So iron is not a mineral, okay? Iron is a chemical element. All right? So minerals are made of chemical elements. So there are 2 types of minerals that can be harmful to our health. Those that have a chemical composition that contains a toxic elements, and those that are harmful because of their form. For example, galena. Where is galena here? Galena is a beautiful lead-bearing mineral. Because of the presence of lead, it is harmful from a chemical composition point of view. Orpiment, we mentioned about it. Cinnabar is a mercury-bearing mineral, and I don't know if I can pronounce this in Afrikaans, grenokite. Is there any Afrikaner here? Did I say it well? So grenokite is the only cadmium-bearing mineral that we know in mineralogy. So all these minerals are examples of those that carry toxic elements in their composition. Therefore, if released into the environment, it can be detrimental to our health. But then, what I will illustrate about today in this lecture is an example of minerals that are harmful due to their form. As I mentioned earlier, you heard about asbestos. But asbestos, again, is a group of minerals, not one mineral. It's a commercial name. So I will illustrate the issue with this unknown mineral to you, which is called erionite. What is this erionite? Erionite belongs to a group of minerals that's called zeolite. And as you can see from the chemical composition, there's no toxic elements there. It's just normal calcium, aluminum, sodium, and so on. So there's no harm from a chemical point of view. Where do we find it? It's found in amygdals or cavities or pore space in volcanic rocks. This is a volcanic rock. Inside these cavities, you have these minerals occurring. This is how it looks like in hand specimen, and this is how it looks like under scanning electron microscopes. Fibers, like tubes, but very tiny. Look at, unfortunately, I don't see, okay, it says about 0 micron in diameter. You can just 0.5 micron. Oops, no, sorry. All right. According to studies, this mineral, which is not yet classified as asbestos, is actually much more harmful than the known asbestos so far. What does it do? It causes serious pulmonary diseases, including lung cancer, asbestosis, mesothelioma, which is a type of cancer that is very aggressive. I'm sure some of you have been to Turkey. If you haven't been, don't go. I hope my Turkish colleagues are not listening to my lecture. No, please. All right, so Anatolia is its beautiful city, touristic city. Why? Because they built their houses in what we call volcanic tuffs. What is a volcanic? This is an example of a volcanic tuff. What is a volcanic tuff? Is a porous, relatively soft rock, which is formed by consolidation of volcanic ash and other ejected materials during eruptions. It's a beautiful rock. In Anatolia, they dig inside these volcanic rocks. They form beautiful houses. It has a natural roof, natural wall. Sometimes they form like bricks, and people live there. On a daily basis, they inhale this mineral without knowing that they are actually living in a grave. Only in 2008, a medical geologist investigated and found that 50% of the death from mesothelioma, which is this aggressive type of cancer, is actually due to inhaling this mineral on a daily basis in this environment. So when you go to Anatolia, please wear your mask. If you go, don't be scared, you can go. Just wear your mask. Now, from a geological processes point of view, I mentioned about volcanic eruptions and dust storms and so on. So volcanic eruptions, how do they affect our health? This is an example of Mount Pinatubo in Philippines, which erupted in June 1991, which is the second largest terrestrial eruption of the 20th century. During the 2 days of this eruption, the sky was covered by billions and millions of tons of chemical elements. For example, cadmium, arsenic, mercury. These are all in the air. Keep this in mind when I reach the section about Africa. You will understand why I'm giving these examples. So we cannot underestimate the natural phenomenon or the geohazards on our health. What are the health issues related to each of these elements? Just some examples. Cadmium, for example, it affects our respiratory system, our renal system. Mercury, it has effect on neurological and behavioral disorders. Arsenic, we said already, cancer, cardiovascular, and so on. Fluoride, we mentioned about fluorosis. Vanadium, selenium, zinc, and iodine, they impact on the thyroid dysfunction. Unlike in the past, the thyroid, you know, the gland that's sitting here in our neck, was attributed to iodine, whether it's too much or too less. But there's growing evidence that other elements, such as selenium, vanadium, and zinc in the environment, can also contribute to the disease. And of course, all the gases that are associated with the eruption. These are the short-term effects immediately when there is an eruption, but there is also long-term effect. Lavas that are formed by some volcanic eruptions, if they are rich in alkaline, which is like sodium, potassium, they also contain high amount of lead, uranium, chromium, cadmium, cobalt, fluoride, and so on. So when these rocks are crystallized, with time, as I said earlier, they weather, they form soil, they interact with the rocks, and these elements are all released into the environment. In South Africa, the Pilanesberg is a perfect example of this situation. If you want to know if someone comes from Northwest, just ask them to smile. Is there anyone from Northwest here? Okay, so you know exactly. So fluoride is highly enriched in water in that region. And again, as I said earlier, fluoride is not the only one. Fluoride is an indication of the system, the chemical system. I'm sure if we conduct studies on cardiovascular diseases in that area, we might find something serious happening in that region. I'm not scaring you if you have relatives in Northwest, but it's just an observation. From a mineralogical point of view, we mentioned about erionite, which is formed in volcanic rocks, so associated to volcanic eruptions. And then I'm sure you all heard about silicosis. What is silicosis? It's a lung disease that is caused by inhalation of silica, but not silica as an element, but a mineral quartz. And not all the minerals quartz, there are different types. There is what we call cristobalite, tridymite, and so on. Only one specific mineral of this group can cause the silicosis. Now, why medical geology in Africa? So now I try to illustrate all what I said before through examples in Africa. Why I'm interested in medical geology in Africa, why I changed my religion in 2015, it's all because my colleague here from WITS, the geophysicist, knows how much Africa is known in terms of its geological evolution. I would say 99% of the studies that are done in Africa by Africans or non-Africans, they are about the geoevolution, geohazards processes, natural resource evaluation, mining exploration. That is the focus on Africa. When you go overseas, you attend a conference, the first question you are asked is about this. But no attention on the impact of this environment on health. From a health, before I move to the health, okay. The geology of Africa is very complex. We have a lot of volcanic eruptions, especially in the East African region, this part of Africa. We have earthquakes. Our colleague here can witness on that. We have a lot of dust storms. We have some dust storms here in Africa, in South Africa. We experienced this not long ago. So all this, as I mentioned it earlier, there are contributing to the release of the chemical elements into the air, the water, and the soil, and then into the food crops, and finally affects our health. It's a chain. From a health point of view, the non-communicable diseases, which are chronic diseases not caused by infections, okay? According to the World Health Organization, 77% of all the NCDs deaths are occurring in low to mid-income countries. Africa is one of them. 85% of premature deaths between 30 and 70 also occur in low to mid-income countries. Africa is one of them. In Africa, for example, the death due to NCDs increased from 2.4 million in 2010. Here is the number, 2.4 to 2.8 in 2019. And on this graph, for example, you see that cardiovascular alone is reaching 1 million in 2019, followed by cancer, and then diabetes and chronic respiratory diseases. So these are the leading causes of death overall. I always make a joke about this graph here. You can see that the males, where the females are here, the graph is showing the females are dying less than the males. I think this is the only privilege we have as women. I won't explain why, but if anybody is interested to know, I will explain the reasons at the end. But we should be very happy that we have that function in our body that keeps us safe comparing to males. Thanks to nature. Right, so according to the World Health Organization, these NCDs are due to a combination of genetics, of course, metabolic behaviors, and environmental factors. So the environmental is mentioned, but what do they mean by environmental factors? Basically, the anthropogenic, not the geogenic. Outdoor, indoor air pollution can be anything. Secondhand tobacco, exposure to chemicals, radiation and noise, occupational risks. Yes, these are contributing factors, but is this all? No. There is a very strong focus on risk factors and treatment rather than the causes. And that is where I decided to change my religion to focus, because I know there is a need for understanding of the contributing factors from a geogenic point of view. I showed you examples where the natural environment has direct impact or indirect on our health. Let me illustrate with some more precise examples in Africa. Looking at the geology of the occurrence of arsenic in some part of Africa. For example, in Morocco, it goes up to 199 microgram per liter in surface water. Or according to the World Health Organization, the recommended daily allowance is 10 micrograms. Look how much we have here. In Ethiopia, 278 micrograms. In South Africa, up to 253. In Botswana, 188. On the map here, or the dark gray areas, it's where arsenic is more than 50 microgram per liter. You have seen what happened in Bangladesh. I showed you the examples. From a health point of view, from a geological point of view. Could that not happening also here? If we look at the cardiovascular diseases, the cancer, the diabetes, and chronic respiratory diseases in these 4 countries, I look at the World Health Organization reports, and I plotted this diagram. You can see the same trend. Cardiovascular is the leading, followed by cancer, followed by diabetes and chronic respiratory disease. So you see the same trend in the same country, in the different countries. I'm not saying, please don't take me wrong, I'm not saying there is a direct link between this and this. All what I'm saying, there might be a contribution from this to this, which we haven't investigated, and it is worth investigating. Fluoride, I mentioned about it earlier. In Kenya, is part of Africa, up to 72 milligrams per liter. This is a study by one of my PhD students. 72. And we said that the maximum limit recommended is 1.5. So now imagine people consuming water every day with this amount. In Morocco, 6.58, not too bad. South Africa, 38. Again, if I look at the cardiovascular diseases, the same, 38% in Morocco, 19% and 13% in Kenya. Please, when you say a low number of a disease in an African country, we might not be excited about it. It's not because the disease is not important in that part of the world, it's because the data are not available. Okay, so, okay, someone is saying hello. Thank you, okay. All right, so I mentioned it earlier about cardiovascular diseases as an indirect health effect in a fluoride-bearing system. That is why I look at the cardiovascular diseases in these countries. And you can see it's quite alarming, up to 38%. It's quite a lot. Volcanic eruptions in Africa. Africa is actually a top 5 volcanic regions in the world in numbers of people living close to volcanoes, within a distance between 5 to 100 kilometers. You have seen the volcano in Philippines, how much was emitted during the eruption. Now imagine people living within 5 to 100 kilometers to an eruption without any control, without any precaution, okay? For example, in Goma, which is located here, it's within 20 kilometers of some active volcanoes, excuse me. So you can just imagine the impact of all this on the population and the animals in the area. Dust storms are well known in Africa, as I mentioned earlier. Each year, there's over 100 million of tons of dust that are transported from the westward to over the Atlantic to the Caribbean, Central South America, according to the USGS. And they were studied there, and they were studied, and these studies show that there is deterioration of air quality in those regions, including decline in the coral reef in this region. So what I found interesting that the African dust travels all the way to America and well studied there, but its effects on health in Africa, it is not studied, apart from very few studies here and there. There is an article, recent review article that came in 2024 that looked at the health issues caused by dust storms in Africa. And there is a clear indication of increased incidence and aggravation of lung diseases, including asthma, influence. Also, the dust could influence the fetal lung development before even the baby is born, and the respiratory system after birth. So you can just imagine how many people are suffering from these issues in Africa. So what is complicating the situation on our continent? Climate change, geomorphology, droughts is one of the major issues. How does it impact on our health? You might think it's too far, but there is a link. When there is drought, which we know that because large parts of Africa are arid or semi-arid, this impacts the uptake of essential elements by the food crops. So our foods, the crops that we plant, especially people who are living in rural areas and desertic areas, basically they plant the carrots, but they are not eating a proper carrot. They are eating a piece of something, like a piece of paper, because there's nothing in it, because there is no water to help uptake of chemical elements that are necessary for our well-being. The soil is deficient in essential elements due to geological background. There are some rocks, maybe my colleague here will help me. In geological terms, it's called quartzite or sandstone. You know sandstone. Sandstone is made of quartz. Quartz is made of silica. So if you plant vegetables in a sandy, quartzitic soil, what is going to be inside this vegetable? Only silica, nothing else. Or we need iron, we need magnesium, we need all other elements. So that also impacts the concentrations of elements that are required for our body. And of course, when there is drought, there is increase in dust storms. And again, as we said, that is why we have all these dust storms happening. Then the flood, to the contrary, how does it impact? The flood, when there is too much, it affects in two ways. Either it flushes all the good elements from the good soil, take them away, or brings bad elements from mining areas to the good areas, and it's a mess. Socioeconomic issues. Life in rural areas, factories and mines. We are all aware that Africa is not just, there are not many cities like Johannesburg. Most people live in rural areas, which means they rely on their immediate environment for their daily food, water, and so on. So whatever is in there is what they consume on a daily basis. Consumption of contaminated soil, clay, rocks. You might also know about the habit, which is a cultural or a traditional habit, not only in Africa, also in other parts of the world, where people consume soil or rocks. It's called geophagy. It's like some of us like chocolate. Some people just crave for that type of soil. Yeah, termites. For termite mounds, sorry, not termite mounds, they just go there and dig and eat without knowing what's in it. We run a project in Namibia, and it's amazing how much toxic elements are found in those termites mound. And the people just eat it because they think it supplies iron, especially pregnant women. They ignore that there is danger. Okay? Poverty, of course, limited access to effective care and health care service. This is all one basically vicious circle. And finally, of course, mining, dams, quarrying industry, cherry on the cake. What are the consequences of this geo-environment, natural geo-environment on our well-being? Certain non-communicable diseases are not classified in the list of the threats. Fluorosis, iodine deficiency disorder, diabetes, okay, diabetes is one of them. But these diseases are not classified as threats, but they contribute to the socioeconomic development. They cause physical disability. If people are physically disabled, they are prohibited from social and workspace. I ran a project in Kenya. We asked people who have fluorosis in the teeth if they work. They said no. Why? Because they are shy. They don't want to smile because they show their teeth. So there is a social impact of that issue that prohibits them from entering the workspace because they are embarrassed, because the teeth can be really, really damaged. I have seen examples. Okay? So this has implications on financial and emotion. It causes a financial and emotional burden. It enhances poverty because people cannot work, so they remain poor. And as a consequence to that, we create inequalities. So there is a serious impact of our geo-environment on the socioeconomic development, which renders the achievement of the United Nations Sustainable Development Goals very difficult. So how can medical geology research contribute? I go back to why I started this. The medical geology research contributes to various interlinked SDGs. Number one is to ensure good health and promote well-being, because it's the key for achieving any other SDG. If people are in good health, that enables them to face various challenges in different social and economic environments. They sustain themselves. They work. They are not poor. Okay? Good health leads to the reduction of poverty and inequalities, and of course, reduction of hunger. It's a chain, but all around the health. If we don't address the health issue in Africa, I am afraid it's difficult to achieve the rest of SDGs. As the Chinese proverb say, give a fish to someone, you feed him for a day. Teach him how to fish, you feed him for the rest of his life. This means if you just give food for people, we see all these charity organizations coming to Africa giving food for the poor people. It doesn't help because you cannot feed them for the rest of their life. Help them to cure from the diseases. Find the cause of the disease and kill it. That is the way you can help. It's a long-term process. It's not something that happens within a short period. But again, it's an important thing to do if you really want to solve the problem. So now what is our contribution from a medical geological point of view? One thing that we do. We identify and we map the geogenic sources of toxic elements or excess of potentially harmful elements or deficiency of essential elements which are required for healthy living. We go to the source and we identify the problem. Where is the problem? How can this help? It helps to reduce or prevent health issues caused by food crops grown in contaminated soil or the soil that is lacking essential elements for healthy living. This is SDG number 2. Drinking irrigation with contaminated water or the water that is not good enough in terms of essential elements for healthy living. That is SDG number 6. Use of uncontrolled energy supplies, such as burning coal containing potentially harmful elements or toxic elements. I showed the example of arsenic earlier. That is SDG number 7. So just by doing this, we can contribute to all this. Okay? In addition to that, education. In my humble opinion, in 2025, everybody has the right to education. But the quality of education that I refer to here is curriculum development, knowledge integration, and implementing of multidisciplinary approach. If we continue to teach our students in isolation, in boxes, biology, geology, geography, like we were taught 50 years ago, we will never achieve much. We need to create niches of research where we cross the borders, such as medical geology. So geology, for example, is not just about mining. Geology is about health. Okay? SDG 4. Gender equality, I love this one. We continue to wonder why there are no many women or females in higher education sector or universities, or they are still rare. When I came to South Africa in 2000, I was the first female academic at University of Pretoria with a PhD. In 2008, I joined the University of Johannesburg. I was the first female geologist with a PhD. Now we have many. But there are still places in Africa, in South Africa, where female geologists are not present. I am the first female geologist to lead an international union. 63 years old international union. Why it had to wait until 2025? So there is still lack of presence of females in the geoscience sector. When we change the perception of geology is a male field, because that is how the perception I had when I was a student was geology is all about men. You have to dress like a man, you have to work in a mine, you have to behave like a man, otherwise you cannot be a geologist. Later on, I realized I can be me without being a man, and I can still do geology. So that perception helps to change and to contribute to these inequalities. And I can illustrate that right now. For the last 25 years that I have been working in South Africa, as I said, until 2015, I had no postgraduate students because I was working on a boring subject. From 2015 until now, I graduated, I can't remember how many, but over 20, 25 postgraduate students. Most of them are females. At the time I'm speaking, I have 3 PhD students, females, 1 male. And because I incorporated health into geology, these students felt safe to come and work with me on projects. They come from different countries. Michaela comes from Mozambique. Sharon comes from Cameroon. Renee comes from Free State, South Africa. Each of them is working on a topic that brings together the health and geology. And each of them is co-supervised by at least 3 supervisors from different parts of the world. Why I say that? Because, okay, these are also my students, the master students. These 2 completed recently, and this one just started. Again, they work on projects that are all related to health and geology. Right, I mentioned that each of them works with at least 3 co-supervisors. This is in line with SDG number 17. The nature of medical geology is multidisciplinary, which means collaboration. We cannot work on a project in medical geology by 1 person or 2. We need toxicologists, we need biologists, we need statistic experts, and so on. So each student is supervised by several people so that they learn from different perspectives. These are the colleagues that I work with so far from overseas and from South Africa, which I take this opportunity to thank them for their support to all my students. All our work that I didn't want to go into the details about the project of each student because that's by itself is a presentation, but everything is, the research we conducted by the postgraduate students is all published. If anyone is interested, you just Google me and the Google Scholar, you will find all the publications, and you're welcome to contact me if there is any need for any. And finally, thank you from the Medical Geology group at the University of Johannesburg. And well, I hope you are still awake and not sleeping. I see some eyes are half closed. But thank you very much for your attention and for keeping awake until now. Thank you.
No, thank you very much for that edifying lecture. Prof, I really enjoyed it. It was great. I'm one of those that are still awake, and I've learned a lot from this. I've learned a lot from this lecture. I have maybe one burning question, but let me just ask colleagues if there's any question that you have on this lecture. Let's take a few questions before.
You're welcome. Yes, please.
So any question from colleagues? My question really is on the undergraduate requirements. If someone wants to work in this.
Professor Maury, that was really fascinating, as the president mentioned. So you've basically described planet Earth as being somewhat poisonous in being somewhat poisonous to human health. That's really what it amounts to. And the question I have really relates to the ways in which human life has evolved over the the millennia. So these rock formations have been around for billions of years, way before human life developed. So why do you think we've not adapted, evolved sufficiently well to cope with these poisonous kind of environments that you speak of? I mean, if you look at the human eye, for instance, such a fascinating and complex organ that's evolved in a way that is in response to the light that's radiated by the sun. It's in the visible spectrum. That's an incredible evolutionary kind of development to cope with the environment that we've been exposed to. Why do you think human life has not evolved to the extent that it should have, I think, to cope with this environment that you speak of?
Thank you, Prof, for this very interesting question. So if I understand right, why human life did not evolve in such a way to adapt? Is that the question? Okay. Surely we evolved to some extent, but we must not forget that the Earth is also evolving at the same time. The amount of weathering of rocks that we have now is different than billion years back. So it's like technology. We evolve to solve a number of problems, but at the same time, there are other problems that are coming up that we are not yet ready to solve them. So I think it's like a race between the adaptation of the humans to what is happening, but meanwhile, there is something happening at the same time. We keep in mind that natural processes are very complex. I simplified to the simplest way, because I don't know what is the level. I mean, I know the level. We are all here experts, but not everyone is expert in geology. So I had to go really to simplify the issue. But it is not as simple as I put it in 1 hour. So I don't know if I answered your question. It's a very philosophical question, and I'm not a philosophist, so I try just to answer from a geological point of view. Thank you very much, Prof.
Great, Prof. Mori, and they are great for that question. Prof. Chetty, any other question you'll guide?
Sorry, I've got a question.
Yes, please.
Nicolette from UJ, from Health Sciences.
Oh, good.
So you analyze, I mean, well, maybe you don't, but you take the samples, sand samples, and then you see what elements and all of that are in them. Have you ever tested those, whether it be animal or tissue culture? And because you're saying that you can't prove the link.
Yes.
So, and then obviously in order to prove the link, you've got to then take those sand samples and then, do animal studies or whatever and see what happens to them.
Very good question. Thank you very much for asking that. Okay. Given the primitive nature of this discipline that I just started, as I said, in 2015, I need to equip myself with experts from health, and I'm very happy you are here, because then I will talk to you later. So far what we did not do biological studies, but we do interviews with local communities. For example, when we know there is high salinity in Kenya, for example, the questions we asked were around the issues of cardiovascular and so on. Basically, we play like a doctor-patient type of, and then we do statistical analysis of those kind of results. And within a small area, we try to draw a link between the answers we receive from the people, the population, and the results. But we did some urine analysis from another project. We also found there is a link, sort of what we found in soil, water, and rocks is actually reflected in the urine. But we did not do blood tests. We did not do tissue analysis. It's somehow another stage in the development of medical geology. So I would be very, very happy if your department would be interested in this joint initiative where we can follow the problem from the source to the issue. I know, for example, for all the respiratory issues, asbestosis, silicosis, we need to do tissue analysis. But unfortunately, it's a very delicate procedure which requires experts. And I'm a geologist. I can't operate. Thank you very much.
Thanks. Any other questions, colleagues?
Yes, there is.
Just a question and maybe a comment.
Please.
As you said earlier in your introduction, I got lost based on the title and the information you were presenting until the very last 2 slides or so. What I see is you have demonstrated the occurrence of these harmful elements and maybe the associated disease conditions. What I haven't seen, and I don't think I was asleep, is
I will provide the evidence.
Having known the existence of these harmful elements, any data on interventions that you may have carried out that have led to a change in the condition, so that what I would then add with your title that medical geology assists in identifying harmful elements, and then maybe there's an intervention and the health state improves. That I haven't seen. The other one is a comment on that Mount Pinatubo also eruption. The tonnage of copper and whatever was so huge. If we were to harvest all that, would the risk benefit not be on the side of economics?
Thank you. Thank you very much, Prof, for that. The question and the comments. So now I can provide to you an evidence that you were sleeping when I was explaining. The example about Bangladesh, the arsenic in water in Bangladesh. At the beginning, no one understood where did it come from, what was the problem, until medical geologists, geoscientists actually, who are interested in health, came in and figured out that there is a layer of rocks. As they dig for groundwater, they must not cross that layer because that is rich in, that's a geological formation that is enriched in arsenic. Obviously, there are techniques that followed up later to filter. And from, how can I say, there are solutions in other countries where remediation processes were put in place, but not in Africa. And that is why, for example, we work with applied chemists who develop techniques in nanotechnology. For example, once we identify the problem, we put it in their hands, because our role as geoscientists, medical geologists, is to find the cause. Okay. Once we fund it, I hand to Prof. Felice here, who is expert in nanotechnology. Now she heard about all the issues, up to her to develop the techniques of filtration of water. But there are some other simple things that one can implement. For example, wearing masks when there is a dust storm. A lot of people are not aware of the danger. It's a simple thing, just wear a mask. So I hear you. Yes, we need to lead to solutions, not just problems. But we must keep in mind that medical geology, the reason why it is less developed is because not many people would like to leave their comfort zone like I did and go to another discipline that is completely new and invest in it. So that is why it is still behind in terms of solutions, okay? So the second, I hope I answered your question. Sorry, I know you were not sleeping. I was just teasing you. The comments about the economic, indeed, yes, that's what everybody is interested in. But for me, I'm sorry, as they say, health is, what is it called now? I forgot that say, never mind. So we cannot appreciate the economy if we don't have the right health to appreciate it. Thank you very much. This is a
All right.
question.
Yes,
One
no
more
problem.
question.
I'm James Ogutu. I come from the University of South Africa. I'm a vet by training and an epidemiologist as a result. I just got intrigued, like in those areas where you have very high levels. I wonder whether you picked up an interest in looking at the possibility of some of these elements getting to humans through the food value chain.
Thank you for that question. As a matter of fact, I started a project in the Karoo about copper disease in sheep. And the vets, they know this. The copper gets accumulated in the liver of a sheep. And then if there is stress or something, it gets out of the bloodstream and then the animals die. Am I right? Okay. So the farmers in that area were sure it was not caused by their food that they supply to the sheep. And so the only solution is that when they graze, they get it from the plants and from the soil, and the soil from the rocks. And we did some rock analysis on the soil, and eventually we found high copper content in those areas. Unfortunately, that the student who was working on that project gave up on it. So the next step, actually, which I started, was to analyze the liver that was sold at the butcher to see how much, because people buy that liver, they don't know there is copper in it, because unless the animal dies, if there is no stress, the copper stays in the liver, it's not released into the bloodstream. So people just slaughter the sheep and they sell the liver to people without knowing actually that liver contains high amount of copper. So that is something, if you are interested, I will be more than happy to dig into that project and finish it. Thank you. I think Prof. Majuse has a question.
No, I'm here. Yeah, no, that's fine. Thanks, colleagues. Can you hear me?
Yes.
Yes, no, thanks for all the questions. The question that I had, by the way, I didn't realize that there was a colleague there who also had raised a hand. But my question was really on the preparedness or the level of preparedness that one would have to work in this area. At an undergraduate level, other than having a geology degree, what else can one have to qualify to do research in this space? I know that you did mention, Hasina, that there has to be prepare our students for something like this in the future. But in the intervening period, what caliber of students would you need to work in this area?
Thank you, Prof. Majuse, for that question. Given the fact that this discipline is not yet incorporated into the curriculum of undergrad, although at UJ, I do introduce it at third year level and at honors level already. But unfortunately not, it's only at UG. So the students that I have so far are simply those who are interested. They have interest in understanding their geological environments on health. And what I do, basically the first year, I spend it just teaching them on basic principles of toxicology, epidemiology, just from my little knowledge. And through the co-supervision with other colleagues, we basically give them that training so that they can understand how to deal with the project. But I can tell you that all the students that I have who really have that interest in understanding the relationship between the geological environment and health, they just grasped very quickly the different aspects of the study, and they did very well. So it is a lot of effort from me to basically do that, to fill in the gap that they have before. That is why I said, as part of education, I think our curriculum at university, I heard that you are going to be in Cape Town as Vice Chancellor, which we congratulate you.
As DVC.
Deputy Vice Chancellor. Okay, sorry. I promoted you. It's okay.
Okay, no, but thank you very much.
So I do hope that as part of your portfolio, you help to look into curriculum change and adaptation to the needs of our new generation and the society, instead of just carrying on the same way as we were doing 50 years ago. Thank you.
Thank you very much. Thanks, Hasna, for that very comprehensive response. Colleagues, I'm so looking forward to meeting all of you later today, those that are there in person and those that will be joining us later. This brings us to the end of today's proceedings in as far as the AGM is concerned. I hope that we've all learned a lot from everything that we did this afternoon. I will be making my way myself to the venue right now. There's just one thing that I want to say quickly. Prof. Himla Sudia at some point spoke about transformation as part of what ASSAf is working on. And even in this presentation, we saw issues of gender coming up very strongly. One thing that I failed to mention as part of the reporting, and I think I didn't see it from Prof. Himla Sudia's presentation, it could have been there as well, but it is that we formed what is called the Council Membership Committee, which is led by Professor Chetty. At the moment, there are about 4 or 5 of them council members who are working on this, just to make sure that we really transform in a very, very meaningful way. So this issue of gender is coming up a number of times now, and we are taking it very, very, very seriously. I don't think I mentioned that. And I think with those words, colleagues, I want to say bye, everyone.
Thank you.
I'll see you later.
Thank you very much. Thank you. Thank you, colleagues. Thank you.
Thank you very much, Professor, for the invitation. It's a pleasure, and I'm very proud to be between scientists. It's an honor for me, and I hope that my presence here and the conference of Professor Murray will contribute to enhance the relation and the cooperation between 2 institutions and 2 countries. I would like also to thanks for Professor Murray. I learned a lot about your conference. And I want to tell you that we are very proud about you, what you are as woman, as professor, as geologist. And I think you can be an example about Algerian women, what she did and what she are doing right now. We are very happy. We have in the new government 9 ministers, women. We are proud about what Algerian women did and what they are doing right now in the different fields. They have many fields in Algeria where the women are dominating, like medical sciences, education, and different others. Thank you very much another time, and we are proud about you. Thank you for all.
Thank you. Thank you, Hasina, for that wonderful presentation. Colleagues, we probably didn't hear Professor Majosi's introduction of our speaker, but you've seen the blurb in the agenda item. I just want to share with you that I first met Hasina when she served on the editorial board of the South African Journal of Science. So when I joined ASSAf as executive officer, she was already in that board, and she was just like a breath of fresh air with the humor and whatever. And since then, we kind of friends on Facebook. And she's absolutely passionate about her garden. You see, the best flowers in a garden when they are in bloom. She has these little hens and chickens and kittens, and she sits and works in the garden with all these little animals around her. So her presentation today on medical genetics kind of exemplifies who she is as an individual. She's very much in touch with her nature and her environment. And the other thing she posts a lot about, and she's mentioned a few of that, is her postgraduate students. I've never seen a more caring, nurturing supervisor and mentor like her. And I'm only talking about what I see on Facebook. So from all of us, in addition to what our president has said, thank you so much for gracing us with your presence. She's leaving to fly somewhere tomorrow already. And if you follow her postings on Facebook, you realize that she's a much sought after speaker because the niche of her interest and the way in which she expresses that content is very, very engaging. Sorry that it was so late, and apologize to everybody for the glitches in some of the technology. It's something that was beyond our control. So thank you for bearing with us. Thank you for being here. Don't forget to sign the attendance register and the other attendance book. And I hope you will join us for some refreshments outside and then for the inauguration of the new membership and award ceremony later. All here, be cool. The thunder and lightning came and the rain came to bless the occasion. So with that, colleagues, thanks once again. And let's go and enjoy some mingling on the outside. All the best.